We've spent a lot of time looking at JavaScript, looking at authentication, talking about HTML, talking about Python, talking about Flask, and talking about App Engine. But we have spent less time on how these different applications are actually operating. So this particular lecture is going to talk a little bit more about cloud, the history of how we got to cloud, containers, and how all of this operates today. So I think this is an interesting history because I think if you pay attention to this, there's some cyclical nature to the way that we've approached computing over the last 60 years or so. So time sharing, if we go way back into the 60s, this is before my time, way before my time, but the idea of a single computer doing many jobs gains popularity. Basically, this was the point where you had a computer and it would do several things. This is the first point where everything was running on a single machine. We had one big monolithic mainframe, and what this particular computer would do is, we'd start to think about having it do multiple, like now we kind of take multiple applications for granted, but way back in the beginning of computing, computers really did one thing at a time. Multi-threading, multitasking, that's kind of a new, it's a later activity here. And then, by the time you get to the 70s, these mainframe computers service lots of clients. So the clients were really thin. If you look at this idea of a thin terminal, basically this was your terminal to access the machine, but it didn't do much other than connect to the machine. So you had these mainframes originally. You start to think about how they're going to do more things, multiple things, all in one machine. Then you get into the idea of multiple, very simple, thin clients connecting to them. Then, by the end of the 70s, into the 1980s, we start getting into the desktop computer, the personal computer. And this is where we're taking a lot of the functionality and we're putting it onto a machine that might sit on your desktop or under your desk. So really, we're moving the computing to the user at this point. And then by the time you get into the middle of the 90s, we're getting into the internet. And now the idea behind the internet is that you've kind of moved back to these servers. You've moved back to the computers that are doing many things but providing access via thin clients. So, we had all of this power on our desktop, and you still have that power, but ultimately the 90s begins where we start doing a lot of the work on the server, and the computer is now just a client. It's just a browser that's going to render HTML on your screen. So we've kind of gone back a little bit to this idea of terminals once we start the internet or start getting onto the internet. And then you get into software as a service. So Salesforce started this idea. I mean, they probably weren't the ones who started, but they're definitely the ones who made it popular. In the late 90s, they came up with this idea of software as a service. Basically, you pay a fee to access software, and they host it, and they provide all the capability. And you move more to data centers. So now you're doing more and more work in a data center, which is not terribly different from trying to operate, this mainframe with thin clients. Now, it's kind of interesting. We keep going back and forth through this cycle of having a lot of work done on a server to having a lot more work done on your local machine to having a lot more work done on a server to having a lot more work done on your local machine. And you can kind of think of smartphones as a step in this process. When smartphones were first created, you were doing most of the work on the server. Then smartphones became very, very powerful, and you started doing more and more work on your local device. And I think that, with Amazon starting to get into Amazon Web Services in the 2000s, now you're kind of thinking not even of accessing the data center. You're more thinking of accessing these cloud services. And then I think in the last few years, containerization has become pretty popular as far as a cloud service. And we've been using containerization all along with App Engine. So containerization, it allows you to have a couple of advantages. One of those is portability. And this allows you to take your applications from provider to provider without having to lock in. Now with App Engine applications do run in App Engine, and you're not necessarily locked in, but it is, kind of using the Google infrastructure. But if you build actual containerized applications that are working with one of the other container providers, you do have a little bit more capability of moving from one container server to another container server provider. So what is a container? It's a good thing to kind of get into. A container is kind of a package of software. We might think of it as a unit of software. And a container is going to contain all of the application code, all of the dependencies, all of the needs, everything that you need for this application to operate. The nice thing about a container is that once you've got one of these container servers, you've got the ability to move between environments because all of your dependencies are there. So you've got your code, your runtime, your system tools, your libraries, all your settings, everything is there. So it doesn't matter what OS you're on, it doesn't matter what provider you're using. If you've built your containers properly, if you've containerized your applications properly, then you can move between these pretty effectively. It's less overhead than a VM because if you think about a VM's operating, running an operating system, it's running all of these different pieces. You might not need the entirety of the VM, and containerization allows you to put potentially many containerized applications within a single VM. So it's smaller storage, it's smaller packaging, and probably less management than owning an entire VM. So the biggest advantage here is that it decouples your applications from both the environment and the resources that they use. Now, one of the issues is how you isolate these containers from each other. Also, statelessness. How do you actually make sure that you can store this state? And I think those are concerns. And statelessness, we've already kind of run into that with our App Engine applications because if we do have a proliferation of different instances, we don't have shared memory across all of those. We don't have shared sessions. So we could be doing a lot of work to duplicate things, because the state is difficult to share. Now, a couple of examples of systems that you might have are container systems. Kubernetes is a very popular one. Docker is also another popular one. There's Rocket. Red Hat has OpenShift. So there are a variety of these container services, and you can kind of pick one if you get into containerizing your applications. Now, one trend that's happening right now, and containerization is helping with this, is this idea of multi-cloud. So this is using multiple services, multiple providers across, infrastructure as a service, platforms as a service, software as a service, and this gives you some benefits and advantages. We're not talking about hybrid cloud when we talk about multi-cloud. Hybrid cloud is really more thinking about running some of your work in your own infrastructure and some of that in a cloud provider infrastructure. And maybe that's because of scalability, maybe that's because of affordability, maybe that's redundancy, maybe it's just for stability. There's a variety of reasons you can do that. And some of those are similar reasons why you might want to use multi-cloud. One reason you might want to use more of your own infrastructure is if you have data residency requirements or you have restrictions on where you want data stored. Maybe your own local infrastructure is valuable for that, but sometimes you want to augment that with cloud services. And the reason why companies will do this, one is policy. Like maybe they do need to operate in multiple places. Maybe they have different, maybe have data residency requirements, or they have operating requirements for local, regional and local policies. So that can be one reason. Another reason is risk. There have been outages in cloud services, and that's not unique to any particular cloud service. But if there's an outage in your entire cloud service, then you might run into trouble if your entire application depends on that one cloud service. So some companies have some of their infrastructure in one cloud service and some of their infrastructure in another cloud service, and that allows them to keep operating if there are any issues there. Cost may be another reason. You may figure out ways to optimize costs moving across these different providers or having this split across multiple providers. And, it could also be flexibility, being able to optimize the use of these different applications. There's a lot of reasons why companies might choose to deploy their services across multiple cloud environments. So some of the trends that we're seeing in cloud right now, multi-cloud is a trend where you're seeing just a lot more customers using a lot of cloud providers for that redundancy ability or for flexibility. It allows them to kind of make choices a little bit more broadly based on where they want to put their applications or their containers. So microservices are another area where you're seeing more development. The idea is you just have these small services that do a particular thing. They're easily testable, easier to integrate into applications. applications. Serverless is an interesting place where you're getting into being able to have scalable resources on demand without actually having to provision a server. Function as a service is another one that is probably taking it one step farther, where you basically have event-based code execution. You get a request and you execute a particular process, and this allows you to really reduce your infrastructure, especially in cases where you're not using, you don't have a frequent call to something. That might allow you to minimize your costs, and that's something that we think about a lot in cloud computing. It's not just the costs are no longer just compute, memory, storage, networking. You also have to think about how all of these things have monetary costs when you're working with cloud services. High performance computing is another space where you just have specialized hardware or massive amounts of computing power. When you get into machine learning training, this is actually something that you see a lot, because you can harness many machines and train models more quickly than you might have to do if you were using your local resources. And that might also be things like GPUs or tensor processing units that allow you to focus this particular type of training more effectively. Hosted services, expanded capability, even entire applications are more and more common in hosting or hosted in cloud environments. So I think that you're seeing a lot of different things that cloud providers are doing. If you take a look at some of the latest offerings from Google, some of the latest offerings from Amazon, some of the latest offerings from Microsoft, you're going to see a wide variety of tools from machine learning, artificial intelligence, storage, all sorts of other specific applications. So I think that if you take a look at any of their sites, or you go look at some of the latest developments in those spaces, you're going to see that they're all offering a variety of services, a variety of capabilities, and many applications that can be hosted in their infrastructure. So hopefully that was a useful overview of the cloud industry as well as containerization. That might help you as you move beyond this class and start thinking about how you can apply these skills in your careers. Thank you.